Good afternoon, ladies and gentlemen, and welcome to this episode of Science Weekly.
Science!
Today, I'll be joined by a very special guest, Travis Decker O'Brien, physics student. Hey, Travis.
Hey there, Caleb. What are we learning about today?
Well, we're learning about gravity and its effect in our solar system. So, what do you know about our solar system?
Well, I know that in our solar system there is a sun, and around this sun there revolves planets. And some of the planets even have natural satellites, which are usually more known as moons.
That's so interesting. So, we all know a little bit about the moon. We have one ourselves. It's big, it's white, it hangs in the sky, and when it's full, werewolves tend to turn. You know, we can even set a pretty romantic mood. But let's talk about the hard facts.
Well, Caleb, I know that the moon has a mass of around 7.35 times 10 to the power of 22 kilograms.
Whoa! That's more than 3 walruses!
And I also know that the speed of orbit of the moon is around 27.3 days at 1 kilometer per second.
Wow, that's super fast! Whew, whew, whew.
And on top of all that, the distance the moon is from the Earth is around 384,000 kilometers.
Oh boy, that's longer than my walks in the morning. I like really long walks. On beaches. You know what else is on beaches? Water. And that's what we're going to talk about next.
Whoa! I felt like I was surfing. Have you ever been surfing, Caleb?
Of course not.
Oh, well neither have I. But do you know what a tide is?
Yeah, I use Tide stain remover on my clothing all the time.
No, not that tide, Caleb. I mean the rise and the fall of the sea level.
Oh, yeah, okay, I know what tide is. But what does the moon have to do with the tide?
Well, the moon has everything to do with the tide. While the moon is in orbit around the Earth, it has a lot of centrifugal force. And this centrifugal force is greater than the moon's gravitational pull. This causes the ocean water on the opposite side of the Earth from the moon to bulge out, causing what we know as high tide. But there must be a way to calculate the force of gravity between the Earth and the moon, right, Caleb?
Yes, there is a way to calculate that. And that brings us to the physics formula fact portion of our show. But wait! Now I'm ready. Remember, kids, safety first. You're asking about the formula, Travis. The formula is F, which represents the force of gravity between the two objects, equals G, the known force of gravity, 9.8 meters per second squared, times the mass of your first object, times the mass of your second object, divided by d squared, the distance between the two objects squared. Calculator time. So, the mass of Earth is 6.0 times 10 to the power of 24 kilograms. And then the mass of the Moon is 7.35 times 10 to the power of 22 kilograms. And those two things have to be multiplied together and then multiplied by 9.8. Calculated all that, we've determined that our first step, which was to multiply the mass of Earth by the mass of the Moon by the force of gravity, 9.8 meters per second squared. We did that, and what the answer we got was 294.147 times 10 to the power of 34. Then, you have to divide that by the distance between the two objects squared. The distance is 3.8 times 10 to the power of 8 meters squared. So that answer was 14.44 times 10 to the power of 16. Then you just divide those two numbers together to leave you with a nice even 20.37 times 10 to the 19 newtons of force. And that is the force of gravity in between the Earth and the Moon.
That's a lot of force.
The force is strong with this one. Now, that brings us to our musical portion of the show. Cameraman, drop me some fat beats.
What?
Yeah, here, it's 2014. Science. 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 Yeah, man, we know that science is so cool. You learn all the subjects during school. Physics is the best, man. Physics is the best. Really puts your knowledge of the world to the test. And physics. Yeah, physics. Today we've been teaching you about some orbits. All this facts, man, you better absorb it. We ain't just here to joke around. If you're not gonna learn this, we'll throw you to the ground. Yeah, physics, science, what? Yeah, man, planets are so cool. They'll just teach you around, so don't drool. Yeah, what? We're doing some formulas. Where's your formulas? What? Science. Chicka chicka bow wow, science. Yeah, science. Yeah, what? Oh, 24.
Word. Wow, that was a really good rap, Kalen.
Thank you, Travis. That was actually a Kalen Cox special there. We're hitting the studios in March, so stay tuned for our first album.
Wow, cool. There is always one thing I've wondered about the moon, though. Like, why does it stay in orbit? Why doesn't it just fly into space or crash down to Earth?
You know what? That's a very good question, Travis. Because if the moon did happen to crash into Earth, well, we would all die. Fortunately, that doesn't happen. So, let's do a little scale model here, shall we? Let's say that this string is the force of gravity. Calculated 20.37 times 10 to the power of 19 newtons. As the moon orbits the Earth, there's a centripetal force that pulls the moon towards the Earth. Luckily, there's a counteracting and balancing force called a centrifugal force that pulls on the Earth and keeps the moon in orbit. These two forces cancel each other out, so the moon just keeps on orbiting the Earth. Orbiting. 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 Well, folks, that's about all the time we have today. But before we go, Travis, I've just got one question for you. What's the difference between a year and a light year?
I don't know, Caleb.
Well, one just has a couple less calories. Well, Travis has got a French ISU, so, say goodbye.
Bye, guys.
Thank you very much, ladies and gentlemen, for joining us for this week's special of Science!
Science!
Weekly. Next week, join us, and we will talk about everything from the walrus flubber to everything you can do with the word nasal plug.